Hello, everyone. And again, thank you so much for joining in. In this webinar, again, like Kunal said, we'll be discussing about Kubernetes Gateway API. Before that, introduction to myself. So I'm working as a Director of Technical Evangelism at Civo, and I am a CNCF Container Traffic Ambassador. I'm CK, CKAD, and CK Certified, and in Flux Ace. I run a couple of more shows like the Search Magic on cloudnative.tv, YouTube channel, that you can subscribe to, where I do cloud native streams. And I am also an author of book that is focused on Kubernetes CKS certification. You can find me on Twitter at Saiyam Pathak and ask me over there or see what work I'm doing for the community. So yeah, today we'll be discussing all about Kubernetes Gateway API. Very interesting kind of a specification it is, and people are I mean, there are a lot of implementations that, like Blue Edge is one of them that has implemented the Kubernetes Gateway API specification, and you can use the gateways and create the gateway classes and some of the objects using Blue Edge, which Kamesh will be demonstrating. But what I'll be focusing on is like what a gateway API is, why it exists, and what is its controller, how it works, and a very common question of gateway API versus the Ingress. Actually, there are a lot of comparisons like gateway API versus service mesh, gateway API versus Ingress. So we'll try to cover some of these and see if it clarifies some bits. So let's get started. So in Kubernetes, when you talk about Kubernetes, Kubernetes is orchestration engine, and it works on pods. So basically you create pods. So whenever you deploy your application, you will create a pod for that, or a deployment for that, which internally will create a pod. So when you create a pod, in the end, your end goal is to expose that, so that the customers or the users or the end users can can reach your pods. Basically, it will be applications that you'll be hosting, and you would want people to reach to access the application, and internally that will be your pod that will be serving out the traffic. So the expose that your pod that can be accessed from outside the cluster can happen in different ways, like a service load balancer. You can have a cloud controller manager, and you can have a directly create a service object and specify the type as load balancer, and then depending on which cloud you're running, it will be giving you a public IP. And your public IP is obviously is accessible. Public means public, it is accessible from outside the world, and then you can access the pod, because service internally is attached to a pod using the endpoint. So service then with the help of label selectors, it gets tied up to the pod, and then it creates the endpoints where it has to hit. So that's how service load balancer works. Then you have Ingress. Obviously, we'll be talking about more of Ingress. The main thing that today we'll be discussing is the gateway API. So this is another way of exposing the pods to the outside world. Before diving into anything, just want to quickly highlight on two things, which is the L4 and the L7 load balancers. So this all that is happening, you are hitting a particular giving a particular request, and it is going to a particular pod. Basically, it's load balancing that is happening. And how load balancing happens, it can happen there are two very common ones, which is L4 load balancers you might have heard of, and L7 load balancers, and sometimes it's L4 L7. So L4 is basically working on layer 4. So layer 4 of the OSI model, which is the transport layer. So it manages traffic, it manages the TCP UDP traffic management that happens via the layer 4 of the OSI model. Now here, if you see, what happens is there is a client. So this is a client and a client connection that is coming, and here is the load balancer, L4 load balancer. Now what L4 load balancer will do is it will terminate this particular connection, find to which backend it has to go to, and then it will reinitiate the new connection to this particular backend. So that's how, I mean, very simple that it works. It doesn't care about the application information. So unaware of any application details, it is unaware of any HTTP, the protocols, the routes. Like if you want to go, for example, like Saiyam .com/v1 or /v2. So it's kind of unaware of those routes. I mean, you cannot route based on that in this particular load balancer. That's where the L7 load balancing kind of comes into picture. So L7 is based on like it's 7 is the seventh layer. So seventh layer of the OSI model, which is the application layer. So it works kind of on the application layer using the HTTP protocol, and it's basically the intelligent routing decisions that it can take based on the HTTP requests. So the one that I mentioned before, like /v1/v2, this going to a specific backend, this going to a specific backend, can be done using the L7 load balancer. So how it works is you client does a connection. There is a L7 LB. It will again terminate the connection just like L4, but now it inspects the message. So it will inspect the message, make the routing decision based on the message inspected, and then initiate a new connection. So that's where the intelligence lies in. Obviously, there when you go, like you'll be, if you go to the core networking, you can read about all the data packets, how it flows, the networking layer, how it comes into picture, and all that stuff. But we are not talking about that aspect. So just wanted to give you a very, very, very like 30,000 feet overview of like L4 and L7 load balancer that is there. Now comes the Ingress. So again, before going into the gateway API, want to talk about Ingress as well. So we talked about service load balancer. Now we are talking about the Ingress. So for using the Ingress is a Kubernetes object. You can use Ingress if you have, obviously you need to have a Ingress controller. So it depends on the Ingress controller. So you will be having an Ingress controller, so that that can, whenever you create an Ingress object, it will automatically manage dynamically all the mappings that happens for that particular Ingress object. And it is exposed either as a load port or as a load balancer, or as a node port. And you can specify. So let's take this example. This is basically Ingress object with the rules. So in the rules, we have specified a host name, which is sayampathak.com. Now we are going to sayampathak.com, but there are like other paths, like star means any other paths, and there is one path which is v2. So we want to do different kind of routing based on that. So what we do is we define like based on HTTP, we define the path section. In that, if it is /v2, then choose the backend as a service which is named v2. If there's nothing, like if there is a star, then choose the backend with a service v1. So that is what is happening here. So if you hit any URL, sayyam.com/abc or anything which is there, it will directly redirect to service v1, and obviously service is associated to the v1 pod. It will be redirected to that particular pod. If we do /v2, then it will be redirected to service v2, and it will be redirected to that particular pod. So that is how Ingress works. Now, obviously, it is serving the traffic. It is serving the traffic, and it is solving the purpose. Like I'm not creating multiple load balancers for multiple service. I'm just using the Ingress kind of objects, and I just have one which is a node port, and then I'll just be creating different Ingress objects with different hosts, and I'll be using my routing the paths, and sending the traffic to the desired pods, desired services, which internally obviously goes to desired pods. But now, why now the gateway API? Let's talk about that. Now we already have the purpose, which is serving. Why gateway API? So Ingress natively can do the HTTP host matching, the path matching that we have done. Like you have different path, host. So all these things can be done, TLS, and so on and so forth. But it is not, there are some of the concepts and some of the features, some of the extensibility things which are missing. And that's where the Kubernetes community has come together. They have put a new specification, which is Gateway API, much more extensible, much more portable, expressible, and role-oriented way. I already said all these, but now I'll say that slowly. So Gateway API is more of a role-oriented thing. and it is portable. So portable is kind of not I would say a feature. It's basically a portable specification. Now I'll touch on this point when I talk about the implementation. So it's basically like all the features, all these features that I'm talking should be portable across different implementations. But there are certain things which are kind of custom, which are kind of not portable. So it is more expressive, like even header based matching, traffic weighting, traffic splitting, all these things can be done very natively, easily, sorry, using the gateway API. Although this can also be done using Ingress, using the custom annotations. So you can have your custom annotation specified, and you can achieve all these things. But again, it comes out to be a more native way to do this. Plus, it is more extensible, means it allows the custom resources to be linked to various objects in API. Plus, it can be used for routing for gRPC. Additionally, it can have different backends. Now you have seen the backend as a service, but it can have different backends like CADE services, buckets, functions. So you can do a lot of things with Gateway API. Now these set is kind of custom. So means it is a custom implementation for this particular specification. So it will be custom to a specific provider that is out there, and this can be non-portable. So it doesn't need to be portable, but all these other features that I just talked about, header based matching, traffic weighting, and all that, these should be portable across different implementations of Gateway API. So what a Gateway API is, so Gateway API is a specification. It is managed by SIG network, and all the implementations, just one example which we'll be talking about is Glue Edge. So all the implementation adhere to this specification, and so like just products adhere to these specifications. And there are the gateway resources. So there are different gateway resources that can be created, and all they are managed by the gateway controller. So just like you have Ingress controller, you have gateway controller. With the help of like gateway controller, you'll be able to create a gateway class. So with the gateway, after you have the gateway class, so basically the gateway class is kind of how your gateways will look like. So your definition of different set of gateways, how your gateways will be. And then you have basically the templates, you can say. Then you have the gateway. So you will be creating a gateway object. I will show the examples of this, not the demo portion, but I have the snippets. So then you create the gateway object, and these basically, and then you create different HTTP routes based on different application needs. And different applications, as you can see, can use the same gateway, and take different intelligent routing depending on the rules that they defined inside the routes.
There's a question someone is asking, will we be discussing on custom resources?
No, custom resources I'll not be touching on. So then you can just imagine for now that the gateway, the functionality of gateway plus HTTP route resembles to a Kubernetes Ingress resource. So just like we saw, right, here it is able to do this particular thing. I'll show you what a gateway is and a gateway and a HTTP route is, but it can be this. Now you can see three kind of personas over here. These correspond to roles. So you remember like we talked about role oriented approach of the Gateway API. So it is important because there are different teams that can use the same Gateway API resources. Now each of the roles have specific purpose over here. For example, here the infrastructure provider will be responsible for creating the gateway class, and then the cluster operator will be responsible for creating the gateway, like what the gateway looks like, what is the gateway, who has access to it, what are its policies, and all that. Then is the application developer. So the person who is developing the application defines the routes. Okay, what all routes to this particular application. So that is where it is divided level by level as per the responsibilities in a project, which we all see. So we actually have a cluster operator, infrastructure provider, and then we have the application developers. So each person can do their own jobs, and they do not need to know what a gateway, what are the specifications of the gateway. They do not need to know what are the, these people do not need to know what gateway class specifications are. So that's how it is abstracted away from the people, from the roles, to be specific in this particular scenario. So gateway, where is the, okay, so we talked about these. So gateway class, now this is a sample gateway class. So you can see it's like a normal Kubernetes object. It's a kind gateway class. Now in the spec section, we have the controller. So I told you, like all the gateway classes will be, you will be giving the controller details, like what is the controller for that. Now, sometimes a controller would require some of the configurations. They can be given as parameters, which is parameters ref and a config. So you can, give some specifications that you can provide, like IP pools and all that stuff, from where the gateway can pick up the IPs, etc. So set of gateway definitions, cluster scoped resource, at least one is required for creating the gateways and handled by the controller. Now we have created the gateway class. Now let's move on to the gateway. So gateway is basically defined from this particular class. So we give the class name. So this maps to the class name. Okay, I have not used the same kind of class name, but this will refer to the this particular name that we have, and we'll be using the gateway class name over here. Then we have the listeners. So it listens. So this particular gateway depends, basically is created from the gateway class Acme LB, and listens to HTTP, listens to port 80 for HTTP traffic, and then match the routes, match the HTTP routes that are having the labels gateway, prod, web, GW. So that's how this particular thing works.
There's a question on the screen. How informers are helpful for controllers?
I informers, sorry, I am not sure about like how informers would be kind of helpful. Maybe Kamesh has some insights on that.
Not really, Saiyam. I think
Okay.
I'm not sure like how they are going to play a role here in this case.
Right. And so now we have created the gateway class. We have created the gateway. Now it's the time to create the HTTP route. So HTTP route is again like kind of a Kubernetes object, because it's a simple YAML file with kind, API version, name, spec, all these things are there. And in this, it will be matching. So you can see the labels over here. They are matching. Match any traffic for this particular host. So match any traffic for this particular host. Apply these rules that are defined in the rules section. So you apply these rules, and then it will be forwarded to a particular service, which internally will be forwarded to a pod. So that's how the whole networking will take place. Now again, like we discussed, like there was this is straight from the documentation actually. So what are the differences between Ingress and Gateway API? So Ingress primarily targets exposing HTTP applications with the simple declarative syntax. Gateway API exposes a more general API for proxying that can be used for more protocols. We see like gRPC and all these other protocols can be used, and models more infrastructure components to provide better deployment. So we have seen like you can use different backends, you can have different set of rules that you can do, and more complex scenarios, more complex kind of routing can be done, and management option for cluster operators. Also, for example, if it is kind of easy to implement a new gateway class for infrastructure provider. If there is a new one, it is easy for the cluster operator to create a new gateway. If there is a new gateway that they want to implement and test with, they can create that, and then they can deploy it to production as well in kind of very easy manner. And yeah, it is very easy for the app developer for testing a new version. So just add a kind of, I think there is a field like weighted or something, I don't remember exactly. So you give the weighted kind of, 90 and then 10 within the same spec section that we have seen in the routes. So here somewhere
A question is there for routes, like, so can we create as many HTTP routes for different services?
Yes, you can create the routes. That's the power, right? So we'll be creating that. We can create weighted routes, do traffic splitting natively, very easily over here. Now, again, all these, there are some of the things that is doable using the annotations, obviously using the, ingress objects as well. But this is the more native way of doing it and more extensible way of the handling the complete load balancing of traffic within the from outside world to the cluster. So that's pretty much it that I had for this particular session, like, all the things like what API gateway. So I hope now before